Hello everyone, good afternoon. My papers, the name of my paper is not our presentation has the three danger of silver, robots and trustworthy representation learning for encrypted malicious traffic identification. And I will introduce the background and significance, key problems, exciting work and implications, motivation and challenges. And theory solution is experimental setup, experimental results, and summary. First of all, the background. Identifying encrypted malicious traffic is a key task in network security, and encryption reveals directly useful payload semantics and makes labeled malware data scary. And the self-supervised provisioning is attractive because this can reduce dependencies on labeled samples, but deployment requires robustness and packet loss, packet loading, and for level erosion. So the key problem is the shortcut learning. Recent work shows that some pretrained traffic models rely on servers correlations and shortcut features rather than robot traffic behavior. For example, the header bytes may leak identifiers such as IP address and TCP sequence numbers, and for packet state splits can create evolution leakage. And the market language modeling is mismatched with the semantic encrypted payload bias. So the core question is, how can pretraining learn traffic behavior instead of dataset artifacts? The exacting work have several rules. For example, firstly, the single traffic representation. They use the match dates, byte sequence, byte image, or flow graphs. But this solution has the main limitations. One, model is easily affected by latency, packet loss, or band-wide shifts, or electrical discretes. And second is what still pretraining, like integrate, transformer, and nanoforms. They directly transplanting MMM can learn higher level of data expected shortcuts. And the third is the classical deep learning based classifiers or machine learning methods like the APP scanner, Diao, FNIC, or TKC. This methods is useful with lines, but this methods has less focus on robust multimodal representation learning. And the last is the masked autoencoder transformer, for example, the YTC. The YTC has strong accuracy. It may still be sensitive to shortcut proven input choices. So the motivation of our paper is that network traffic is not a natural language sentence. Robot pretraining should align traffic specific spatial and temporal views. So we will face three challenges. The first is how to avoid brittle shortcuts in sparse and universal encrypted malware traffic. And the second challenge is how to replace ill-fitting NLP objectives with traffic native training. And the last challenge is how to pursue robust cross-model arrangements during tree operation. So the first solution of our method is the multi-model impulse. We design the multi-model impulse. It splits pickup session into flows, and it extracts packet level information and represents each flow from complementary temporal and spatial views. The first model is temporal mandate, such as packet size, packet inter-arrival time, and burst total bytes and burst time intervals. And the second model is the spatial byte image. We use the packet bytes and received into a 64 by 64 3-scale image. Importantly, our packet headers are included to reduce header level short-packet learning and network setting phase. And the last model is a burst distribution map, like burst packets, counts, and burst duration from a joint distribution map. The second and the third model is the spatial model, and the first model is the temporal model. So it's our architecture of the circuits. The left is the pretraining stage, and the right is the fine-tuning stage. In the pretraining stage, we use the spatial temporal feature alignment task to align the spatial model and the temporal model. In the fine-tuning stage, we use the multi-model feature fusion model to align the two model inputs. First, we use the constructive learning to alignment the temporal inputs and the spatial inputs. The temporal inputs and the spatial inputs, if they are from the one flow, we think is the positive symbol. Another is the negative symbol. So the goal is to the goal of the constructive learning is to make the positive symbol closer and make the negative symbol far. The reason why not the maximum long range modeling is that this method is poorly matched to weakly symmetric encrypted payload bytes. Okay, in the fine-tuning stage, we design the permanent tuning and IMFI. The first, we designed the permanent tuning by a two-layer magnet with 2.18 parameters. The purpose of permanent learning is to preserve pretrained spatial temporal alignments when adapting to downstream malware amplification. And we designed the multimodal feature fusion. It's named IMFI. The IMFI projects the temporal and spatial features into a shared space and apply bi-directional cross-attention and mean pooling, and use gated residual fusion instead of right combination or addition. Okay, this is all the implemental setup. We use three public data sets as the pretraining date. They are ISSQR, ISSVPN, and CNIC. And we use two public malicious traffic data sets as the evaluation date. They are UFTLC and CNIC. And we use the flow level split to avoid per package leakage. We use 7 baselines. They are epicenter, Diao, F-Night, TLC, YTC, reports, and transformer. We design 3 scenarios. They are stable, 10% packet loss and 10% packet reloading, and use the top 1 accuracy and FE score, precision report as the matrix. 诶，没了。这里没有。These are main comparison results. In the table, we can see our service has the top 1 average score and comparison accuracy. So Zhang is number 1. And in the evaluation study results, the results shows few services performs better under both 10% packet loss and 10% reloading. That confirms the value of temporal special complementarity and marinite and MFF. We also do the experiment that compared with YTC. Also, YTC has higher average accuracy. Our service improves average score. And when we remove higher bytes from YTC on UFTLC under 10% reloading, we can see the accuracy of YTC drops, but our service also have the high accuracy. So this is the summary. Our service is a robust spatial temporal representation learning method for encrypted malicious traffic identification. The service includes header bytes and avoid reading and bot style MLM objectives, and aligns temporal mandates and spatial bytes mapped through constructive learning. Thirdly, service use traffic specific purpose tuning and MFF to preserve alignment during fine tuning. The last service has the best precision, recall, and score with competitive accuracy and stronger robustness under packet loss and reloading. That's all. Thank you.
Thank speaker for the talk. Or we raise hand for question. Thanks for your presentation. I have a question. How does MFF combine temporal and spatial features, and why is it useful?
Okay. Thank you for your question. That is important. Like this we design the multimodal filter fusion and project temporal and spatial features into a shared space and apply bidirectional cross attention and mean polling. The bidirectional cross attention is both temporal to spatial and spatial to temporal. Lastly, we use the gated residual fusion instead of a right combination or addition. It is useful for avoid the noise than just concatenation and addition.
Okay, thank you.
Thank you.
Thank you for your presentation. It's very interesting on the payment. I think the IP address and the post you do not usually your model in your search.
Yes.
Right. You want to you want to avoid the shortcut.
Yes.
And do you have any other method for avoiding the shortcut?
Yes. We don't use the header bytes. We just use the payload. The payload bytes as the byte image.
Okay. In other time, I think the IP address and the post maybe they will contain some information like for the active of the network. Maybe it's useful.
Yes.
Do you think we can use the IP or post for
Okay. I know. In my opinion, the IP may be useful. This is a paper from the Tsinghua University, the Professor Xuke team named Diffusion use the IP address for pretraining and achieves higher performance than transformer than other recent methods. So I think the IP address may also useful, but is also possible for shortcutting. So we should use the IP address for special ways.
Okay. Thank you.
Thank you for your question.
Let's send Mingyu again.
Thank you.